Okay, so this was a problem that we did about several animations of a ball rolling off a table, and only one of them represented acceleration due to gravity. So we know that acceleration due to gravity has to be just g in the positive y direction if we chose axes that look like x and y from the point at which it leaves the table. And what we found is that to evaluate which one of these is true, we can look at the vertical components of where this ball is. And we see that the vertical components are equally spaced for all time steps. Sorry, the horizontal components, there we go, are equally spaced for all time steps. And the vertical components get bigger and bigger and bigger for the displacement. And that makes sense because what we have for kinematic equations is that y is equal to y naught plus v y naught t plus 1/2 a y t squared, and x is equal to x naught plus v x naught t plus, well, 1/2 ax, but for gravity that's just 0 t squared, and in the y direction it's just g. It's just g. Okay, so this is the one that has to be correct, and the question was, let's measure what the acceleration due to gravity is in this animation. The person who programmed it could have made it anything they wanted. And so we noticed by watching this animation progress that it left the table, so it left the table at t was equal to 1 second, and it landed at t is equal to 1.65 seconds. And we were told that this distance was something like 2.1 meters. And this distance, I guess just this distance actually, this distance was something like 3.3 meters or something like that. But you know, that distance along the ground, that's just a red herring, because the equation for the position is that it just marches ahead, constant velocity. So it's really the vertical situation here that tells us anything about gravity. And so we're going to use this equation here, and we'll use that the final position, 2.1 meters downward, is equal to its initial position plus, and now rolling off the table means that at the instant it left the table, just as it was leaving, it had no velocity in the vertical direction. No velocity. So when it leaves the table, at leaving the table, Vy naught is equal to 0. So back to our equation, so Vy naught is also 0 times t plus 1/2 g t squared, and that's actually all the information we need. So g is equal to, multiply both sides by 2, so 2.1 meters, and dividing by the time squared, which is 0.65 seconds squared. We'll pause there and pull out our calculators. Okay, and we're back, and the answer is 9.9 meters per second squared. So we have a very good idea that this is probably Earth.